Alright, so this is my first YouTube video for geometry of the year. We're in Chapter 1. Test is on Monday and Tuesday. We're going over all the sections we talked about in Chapter 1. So the first one we'll talk about is Section 1-2. And in Section 1-2 we had a point. That's a point. Call it A. So remember, you know these words point. And then if you have 2 points connected, so call this point B. That's a line. Notice the arrow. So you have point, we have line. And then if I draw a parallelogram around these things, and I can throw a third point in there, call it point C, or I could put a capital letter in the corner, call it capital R. I can name the plane with 3 points, ABC, or with just that R, and that's a plane. Remember also, if you have a lowercase letter next to one of the arrows, call that L. That could also be line L. All right. We also talked about array. So array is part of a line, has an endpoint, and it goes off infinitely in one direction. And typically there's a second point on the ray. All right, so that's what array looks like. You could also have opposite rays. Opposite rays are 2 rays, so let's call this ray A, B, and let's call this ray A, C, that go in opposite directions and they form a line. So be aware of that. And then we have our 4 postulates. I'm just going to list them, so postulates. Postulates. So number 1, the first one is through any 2 points, there is one line. Through any 2 points, there is one line. And the picture is just simply point A, point B, there's your one line, called L. Second postulate, the intersection of 2 lines is a point. And here we're going to draw 2 lines intersecting. Here's the 2 lines. And their intersection point is right there in this, where they cross. 3. Through any 3 non-collinear points, there is one plane. So if I have 3 points that are not in a row, I can draw a plane around them. Just one. Just one plane. And then lastly, the 4th postulate, the intersection of 2 planes is a line. And it's kind of a tough drawing to draw. So again, I draw one plane kind of slanted, one plane more up and down. And the intersection is where they touch on the corners here and here, and this line that goes on infinitely because the plane's going on infinitely. That's the intersection line. Right there. So again, that's a very typical drawing if you have to draw 2 planes intersecting. The last 2 words I want to mention are collinear, on a line, and coplanar, on a plane. So be aware of the vocab. Alright, so lots of vocab in section 1-2. Now we're into 1-3. 1-3 was all about these things called segments. So if I have a segment, that means I have 2 points A and B, and it's everything in between. Now, there's this important thing called the segment addition postulate. So say this segment AB had another point on it, call it C right here. So I could take A to C, I could add C to B, and that would give me A to B. This is segment addition, very important concept. We also talked about this word congruent. So if I have two segments, say this is segment AB, and this is segment CD. If they're marked congruent, you'll see the same number of slashes through them. And we say that segment AB is congruent to segment CD, or that the length of AB is equal to the length of CD. And this is used commonly in problems where you set two expressions equal to each other. Now, with this idea of congruence, we're going to bring up the word midpoint. So if I have a segment, say AB, and I have a point right smack dab in the middle, call it M. M is the midpoint. What M does is it bisects the segment. That word bisects is very key. It breaks the segment into two congruent parts, A to M and M to B. So segment AM is congruent to segment MB. Or AM is equal to MB. And again, you can use that in problems as well. And that's all about section 1.3 and segments. Alright, we have section 1.4 now talking about angles. So here's an angle. Call this angle A. So this is an angle. Now if I throw a couple letters out here, B and C, I could name it angle BAC. And then if I have a ray going through this angle, not necessarily through the middle, just somewhere, put a letter there, D. Now I can use what's called the angle addition postulate. Angle addition postulate, which says that the measure of angle, and we'll start on the far left, B to A, and then D. So that's this first angle. So I'll put a 1 there. So the measure of that angle plus the measure of angle DAC. I'll put a 2 here. Measure of angle DAC. So those two small angles will equal the measure of the larger angle BAC. That's a very important postulate. Now sometimes you have a straight angle involved. And a straight angle is just a straight line, just like it says. So this would be like straight angle, angle ABC. And the measure of angle ABC, we have to understand, is 180 degrees. So a straight angle is 180 degrees. We also have right angles. Call this angle A. And a right angle is marked with a right angle box. That's how you know that it is a right angle. Sorry, we also have this idea of congruent angles. So if I draw two angles, call this angle A. The vertex is angle A. Call this angle B. These two angles will be marked congruent if they have arcs inside of their angles. And again, same number of arcs. So we say that angle A is congruent to angle B, or the measure of angle A is equal to the measure of angle B. And that's 1.4 on angles. And now we're on section 1.5, and section 1.5 is more with angles. So we have a lot of vocab here. First, let's talk about what a linear pair is. A linear pair of two angles that make a line or a straight angle. So there's my line. There's a ray going up from this line. Call this angle 1 and angle 2. Angle 1 and angle 2 form a linear pair. We also have this thing called the linear pair postulate. The linear pair postulate, which says that any linear pair is supplementary. So the measure of angle 1 plus the measure of angle 2 equals 180. When you add to 180, you are what we call supplementary. So linear pair postulate, supplementary. Similarly to supplementary, this is the word complementary. Complementary means add to 90. So typically you see a picture of a right angle, and then you'll have a ray going through. Call this angle 1, call that angle 2. The measure of angle 1 plus the measure of angle 2 equals 90 degrees this time. So two angles that add up to 90. Vertical angles are also very important. Vertical angle sides form opposite rays. So opposite rays form lines. So typically we just draw two intersecting lines. Call this angle 1, call that angle 2. Those two angles are vertical angles. And later on we'll learn that the vertical angles are congruent. So angle 1 is actually congruent to angle 2. Which means angle 1 equals, the measure of angle 1 equals the measure of angle 2. So we would set those two angles equal to each other. Same thing here with 3 and 4. The measure of angle 3 equals the measure of angle 4. So there's always two pairs of vertical angles. Another vocab word is this word adjacent and adjacent angles. So adjacent angles are next to each other. So in this picture here, or let's draw another picture. I just drew some random picture. Angles 1 and 2 are adjacent because they share a vertex. They share a side, so this side goes in between them. And there's no overlap, which means one angle does not contain the other. They don't cross over. They are separate next to each other. And those are adjacent angles. I want to mention a couple other things. Remember the problems that involve the word supplement or complement. These are these algebra problems. Remember 180 minus x, 90 minus x. Let the other angle be x and set up your equation. Interpret the algebra. And then lastly, let's talk about an angle bisector. So if I have an angle here, so this is angle ABC. An angle bisector is a ray going right through the middle. And if it bisects, that means that these two smaller angles are congruent. Angle ABD is congruent to angle DBC. Which means their measures are equal and you can create an equation. The measure of angle ABD equals the measure of angle DBC. Okay, and there's all from section 1.5. Section 1.6 had two major constructions in them. The first one is for a perpendicular bisector. And I'm just going to walk through the steps with you. So it starts with a segment. So AB. So remember, you open your compass up more than halfway across AB, and you're going to create an arc here. And then you'll take your point on B, and you'll create an arc over here. And those two arcs should crisscross twice. And then you'll take your straight edge tool and draw a line straight through those 2 points. perpendicular, and it bisects, meaning that this intersection point is the midpoint. And then an angle bisector starts with an angle called angle A. You put your point on A and you draw an arc across both sides of the angle, so you get these 2 points. Then you take your compass and on one point you draw an arc inside the angle. From the other point you draw a similar arc. Where they crisscross, that's that point you need. And now you've drawn the angle bisector because this angle and that angle are congruent. On the geometry page, the geo page of my website, on the far right, there are links. And there's a link called the Constructions, I think it's called Chapter 1, Constructions. If you're at all confused about how to do these 2 constructions, you should look at that link. And then last but not least, section 1.7, distance and midpoint formula. Okay, so if I have 2 points, A, x1, y1, B, x2, y2, to find the distance, D, or you could say AB, or AB, equals parenthesis x2 minus x1 squared plus parenthesis y2 minus y1 squared, all under the square root. And you'll simplify inside the square root first to get one single number and then take its square root. To find the midpoint between those 2 points, we'll simply add the x's, x1 plus x2, and divide by 2. And we'll add the y's. And this will find the midpoint, which is the point right in the middle of those 2 points. So that is chapter 1 in a nutshell. All the stuff you need to know. It's a lot, I know. Study up. Look at my homework solutions. Look at the review answer key. Review your notes and watch and do the bonus. Good luck, and we'll see you on Monday or Tuesday.